So it says, why does a child in a wagon seem to fall backwards when you give the wagon a sharp pull? So this has to do with forces, okay? So imagine a kid in a wagon, and so let's draw this, okay? So I got this kid in this wagon. And perfectly drawn wagon. And so when I take this wagon, and we'll draw a little kid here. Okay. If I pull this way, it's saying that the kid will fall backwards. Why is that? It says that it seems like he falls backwards. Can anybody explain that?
So like when he's sitting there, right, and you pull it, he's got his own force, and when you put the force in the wagon, it stays there. And it's like,
Well, let's try to word that a little more formally. Yes.
His velocity relative to the Earth doesn't change as fast as the velocity of the wagons.
No, you guys aren't really thinking this through. You're just mumbling stuff. You might as well say goldfish or 37, right? Let me explain to you. So, Newton's first law is the law of inertia. And basically what that is stating is that, does anybody know what that is? Can somebody tell me? An object at rest will what?
Stay at rest.
Remain at rest. So there's a lot of stuff going on here, and I'm going to unpack this, and it's going to be an over-explanation, but it's necessary because we need to talk about it. So when I pull on this wagon, I create a force, and that force is equal to the mass times the acceleration, right? So I'm going to accelerate this wagon in this direction. Now, this child, how does he start off, or she? They're at rest. So the wagon is going to be pulled. There's nothing really pulling on the child. So the child is going to try to stay at rest. Okay? Now the lower part of the kid will move, but what happens to the top part of the kid? In other words, his body, if we could look into the wagon, his body is moving this way, right? But his head is at rest, so there's nothing pulling it. So it looks like his head is going backwards, but in reality, his head's sitting still, right? So his head's sitting still. So when this moves forward like this, and the wheels move forward, his body, his head specifically, is going to kind of stay at rest, and then he's going to kind of jerk back like this, right? Holy moly, getting a phone call while I'm teaching. That's not good. So that's basically it. So it looks like a backward motion because his head goes back like this.
his head's still in the same spot it was before because it was still resting there.
Well, technically, yeah. So the argument for the frame of reference is kind of true, but that's not really true. Like, so somebody said, well, the reference of the person with regards to the earth and the movement of the wagon, that's not necessarily accurate. You're correct in the sense that his head will want to stay in the fixed position that it is, and the rest of his body is being forced to move forward. But those aren't necessarily a frame of reference issue, right? So this is all occurring within one frame of reference, right? So if I'm sitting outside, well, I guess you could argue the frame of reference. To the kid, it feels like he's going backwards, right? It might even look like he's flying backwards. It'll feel like he's flying backwards. But if you're from another perspective, you could see that his head's sitting still and the wagon is moving in front of him. But they're asking that, this is about forces. So they're asking this question, like, what forces are going on? In other words, if I pull something forward, why does somebody appear to go backwards? All right? Good stuff.